Good. Very good, as a matter of fact. We need it. If without the greenhouse effect, things would not be good at all. They'd be very, very cold. The greenhouse effect helps keep our atmosphere considerably warmer than it would be without the greenhouse effect. All right, so before we talk specifically about the greenhouse effect, let's go back in time and revisit the electromagnetic spectrum. On the electromagnetic spectrum, we're going to focus on visible light. That's going to be one of the things that we're talking about. And the other one is infrared. And you remember infrared's name is also heat. And the greenhouse effect is all about keeping things warmer. So infrared is heat. You'll also remember that visible light has shorter wavelengths. Remember, decreasing wavelengths to the left. So visible light has shorter wavelengths than infrared. Infrared on the right-hand side, increasing wavelengths. Infrared will have longer wavelengths than visible light. So this is what's happening inside a greenhouse. Greenhouses are able to stay warmer than the surrounding area because the visible light is going to come into that greenhouse from the sun. Remember, 92 million miles away. Here comes some visible light from the sun, and it goes in through the glass and hits everything that's inside the greenhouse. The plants, the pots, the containers, the floor. It's hitting that material, and that material is absorbing the energy. All right, just as if you go outside and sit in the sun and you're wearing a dark colored shirt, it'll absorb the energy from the sun, absorb that visible light energy. When that energy is re-radiated or given off, it's not given off in the same visible light spectrum. It's not given off by the same wavelength. So this is absorbed, and then it's going to be what we say re-radiated, or it's given off again, but this time instead of being given off as visible light, it's going to be given off as infrared. So now we have this infrared energy, but the infrared energy can't get out through the glass. It bounces off the glass. So all the energy being given off by the floor, by the plants, it's going to try and leave, but then it gets bounced around inside. That infrared, the heat wants to get out, but it can't get out. So the heat gets trapped inside. So here we have the basis of the greenhouse effect. A shorter wave visible light comes into the greenhouse. Longer waved infrared energy cannot get out of the greenhouse. So visible light comes in, it gets absorbed, it then gets re-radiated or released again as infrared. And you could see this process happening if you feel the ground in the evening. The road is going to feel warmer. It's giving off that energy. It's giving off that heat. This is what's going on in the Earth's atmosphere. So if we draw the Earth, let's have here, this could represent the surface of the Earth. And we live here on the surface, and there's all our houses and our trees that we live in, and maybe there's the mall, and there's somebody parked outside the mall, and they're waiting, and then someone else was over here getting new tires at Sears. Anyway, so there's the Earth. We have visible light is going to come to the Earth from the sun. So here's this shorter wavelength visible light comes and hits the Earth. This energy is going to get absorbed by the Earth. That energy is then going to be re-radiated as heat. And that heat is infrared. It's a longer wavelength. But that infrared, that heat, is not going to be able to escape because it gets trapped by some gases. It gets absorbed by some gases. So visible light energy comes into the Earth, gets absorbed, it's re-rated as infrared or heat energy, and the gases that trap this heat in the Earth's atmosphere are known as greenhouse gases. And these greenhouse gases trap the heat in, therefore keeping our atmosphere warmer than it normally would. All right, let's focus on these greenhouse gases. There are many greenhouse gases, but the three that are involved in the majority of the greenhouse effect are carbon dioxide, water vapor, and methane. Carbon dioxide produced by volcanic activity, produced by life, Right? We breathe out carbon dioxide, water vapor through evaporation, and methane, which is a gas that's released during decomposition. All right, so carbon dioxide, water vapor, and methane there are others, but those are the three main ones. And one of the things people talk about when we talk about a greenhouse effect maybe being bad, or a runaway greenhouse effect, or global warming, is if you have an Earth that has a whole bunch of trees. Let's say we have a big forested area. Those trees do a real great job of sequestering, or they do a good job of, those are beautiful trees, of capturing carbon dioxide. All right, so they take carbon dioxide out of the air. Well, if I cut down a lot of those trees, they're not going to take as much carbon dioxide out of the air, which means there'll be more carbon dioxide in the air to trap more heat. If we have lots of factories, and in those factories in the process burn fossil fuels and put a lot more carbon dioxide into the air, then that carbon dioxide is going to trap more heat. If it traps more heat, that might cause the temperature of the Earth's atmosphere to increase, which could lead to some negative effects as well. All right. The rate at which the Earth absorbs is going to be different for different parts of the Earth as well. If we focus on just this idea of absorbing energy, we notice that when visible light comes into the Earth, it's going to be absorbed by different materials in different ways. Certainly we notice the difference between a dark shirt and a light shirt, right? So if we have the sun's energy shining down here, some visible light coming from the sun, we have one person who's wearing a dark colored shirt, right? And maybe another person is wearing, let's color this one here as a dark colored shirt. Maybe it's a concert shirt. You know, maybe they went to go see All Time Low when they're real excited about their dark concert shirt. But somebody else is just a nice white tee on. We know that as the sun strikes them, that the dark color is going to absorb more energy, where the light color is going to reflect more energy. So the color, and this happens on the Earth too. If you have an area that has a field, a farmer's field that's dark and has a lot of colors of the Earth, that's going to absorb more energy. Yet if we have a snow-covered field, that's going to reflect more energy. It also depends on whether the surface of the Earth is rough or smooth. If you have an area, let's say this is a land area, and you have one area that has a lot of mountains in it, and then you have another area that's kind of a flat plain, rough surfaces are going to absorb more energy, and that's because as it hits, it's going to bounce around a little bit more and is going to not be reflected as much. That's going to bounce around, have more opportunities to absorb, yet light that hits a flatter area is going to reflect more. So we also see when the terrain is rough compared to being a smooth or a flat plain, that will also affect which one absorbs more. In this case right here, the rough is going to absorb more, where the smooth area will reflect more. So greenhouse effect, good or bad? It's a good thing. It's a very good thing. We want the greenhouse effect. It keeps our atmosphere considerably warmer than normal, and we also know that we also have some changes in how that energy is absorbed.